Hello and welcome. In this video, we are talking about our different types of reactions. We're on page 14 and we're starting with our synthesis reactions, our first type. So that word synthesis means to create something. So we're taking two smaller things and combining them into one larger compound. Sometimes these are also called combination reactions. So we're taking these two small elements or compounds and combining them into one single product. Well, one thing that we're going to be learning throughout these videos is how to predict the products for our different types of chemical reactions. If we have our reactants as just two elements, you need to know how to predict the products. So let's go through our first example here. When we look at number 1, we have magnesium and nitrogen reacting. They're going to form one single product. Well, magnesium's a metal. Nitrogen's a nonmetal. Metals and nonmetals make an ionic compound. So, how do we find the formula for an ionic compound? We have to find our ions and balance the charge. So, we're going to go and find our magnesium ion. Magnesium is in group 2. It has a 2+ charge. And our nitrogen ion. Nitrogen has a 3- charge. We're not going to keep that little subscript 2. That's from nitrogen, the diatomic element. It's going to make nitrogen the ion. Ions are not going to be diatomic. So when we balance our charge, we're going to need 3 magnesiums and 2 nitrogens to make that neutral compound. Anytime that we are finding the new product for a synthesis reaction or any new ionic product, we're going to have to find the correct compound. We can't just squish together what we already have. If we just squish together and put Mg and 2, that doesn't exist. That's not a thing. So again, we have to find our charges and balance them out for the correct compound. Now that we have our correct formula for what we're making, we need to go back and balance it. Well, I can see that my magnesiums are not balanced. We need 3 on both sides, but nitrogen already had 2 on both sides. So here we have our full final balanced chemical equation. Go ahead and pause the video. I'm going to give you a minute to try out the second example here. Resume when you're ready to check that. Be sure to predict the product and then balance the equation. So again, we have aluminum, which is a metal, and oxygen, which is a nonmetal, which are going to come together. Metal-nonmetal is going to form an ionic compound, so we have to find our ions and balance the charge. Aluminum's 3+, oxygen's 2-. Again, we drop the diatomic part. We're not talking about the diatomic element anymore. Balance our charges. We are going to need 2 aluminums and 3 oxygens. Well, then we need to go and balance this. Looking at our oxygens, I have 2 and 3, so I'm going to make that 6 on both sides, and then we need 4 aluminums. So let's go and look at our second type of reaction. Our second type is a decomposition reaction. That word decompose means to break down or break apart. So we're taking one single reactant and breaking it down into 2 elements or its compounds. Most of the time, this is going to require energy to do. Again, this is something where we can predict the products. The only case where you need to be able to predict the products is if your reactant is breaking down into just its 2 elements. So here we have water. It's our only one single reactant, so we know all we can do is break it apart. We're going to break it apart into its elements, so hydrogen and oxygen. We just need to be sure we get the correct formulas for those. Hydrogen is one of our diatomic elements, so it's going to be H2. We're going to make oxygen as well, which is also a diatomic element, so its correct formula is O2. Again, just like we saw with synthesis, we need to get the correct formulas, worry about balancing next. So we got our correct formulas, they're both diatomic elements. Now we'll balance we're going to need 2 oxygens on both sides, which in turn gives us 4 hydrogens that we're going to need. Again, go ahead and pause the video and give this second one a try on your own. Resume when you're ready to check. So in breaking down NaCl, we're going to break it into its elements, sodium and chlorine. Sodium is not one of our 7 diatomic elements, so it's just going to be Na. Chlorine is one of the 7 diatomic elements, so it's going to be Cl2. We need to balance our chlorines, which in turn will mean our sodiums need to be balanced as well. We cannot put a subscript on our sodium because, again, it's not diatomic. When we're balancing, make sure that you're only changing those coefficients, not the subscripts. So in this video, we're going to look at one more type of reaction, and that is single replacement. Sometimes single replacement is also called single displacement. We're taking one element that's replacing another. Our reactants will always be an element and a compound. We're going to form a new compound and a new element. So we see that A has gone and replaced B. B got kicked out alone. We can predict the products of a single replacement reaction, and you're going to need to be able to do this as well, but we can only predict it if we know the charge on the cation that's being formed. So let's take a look at our first example. We have silver reacting with that copper nitrate. We also have to know what element that single one is going to replace. So in this example, our single element is a metal. It has to replace the metal. The compound that we have here is going to be an ionic compound. We can't end up with 2 cations together or 2 anions together. It has to be 1 cation, 1 anion. So since silver turns into a cation with a positive charge because it's a metal, it has to replace the cation in the copper nitrate, which is the copper. The metal, again, the first one is always a cation. So silver is going to replace it. We're going to kick copper out. So now copper ends up all alone, and we make silver nitrate. But I can't just still the subscripts. Again, we're forming a new compound. We have to crisscross to find our charges or balance the charges. The new ionic compound that we're forming is silver nitrate. Silver is one of the ones we needed to remember as a predictable charge in that transition metal section. It always has a +1 charge. Nitrate, that polyatomic ion, is NO3 with a -1 charge. So I only need 1 of each ion for my charges to be balanced. Again, we can't just take the subscripts from the other side. We have to balance the charge, find our correct compounds, then we'll go and worry about balancing. My copper and silver are good right now, but I need 2 nitrates. To get 2 nitrates on my product side, we're going to have to go back and balance our silver as well. Go ahead and pause the video, give the second one a go on your own, and resume when you're ready to check. So on this next example, we're looking at zinc. Zinc is a metal. It's going to form a cation, so it has to replace the metal in the compound. When it replaces lead, lead ends up all alone. It's just Pb is its formula there. And then we're going to make the zinc chloride. Still have to crisscross or balance our charge for those new compounds. Zinc is 2+. It's another one that we always need to know the charge of. It's predictable in that transition metal section. And chlorine is -1. So we're making ZnL2, and this ends up already balanced. Hello, and welcome to part 2 of our types of chemical reactions. We have 2 more types to look at, and then we'll put it all together into some practice. First type is double replacement. A double replacement reaction, we have 2 things reacting with each other, and we're always going to be starting with 2 compounds. This is normally happening in an aqueous solution, which means all these things are dissolved in water. Water is the medium in which the reaction is happening. We have 2 types of double replacement reactions. We have a precipitate reaction, which means one of our products will always be a precipitate or a solid that we made from two aqueous solutions. The other type is an acid-base reaction. We're going to learn more about those later this year, but in an acid-base reaction, we're going to have water as a product. So let's take a look at this. In our double replacement little general reaction here, we have our two compounds. These are always going to be ionic compounds, and we make two new compounds. So what's happening is our compounds split up. Our first metal is going to go with the second nonmetal. A cannot go with C. They are both metals, or they are both cations, positively charged ions. Two positive charges repel each other. They don't want to be by each other. And then C, our second metal, has to go with the first nonmetal. Again, it has to be a metal with another nonmetal, or a cation with an anion, positive with negative, to make an ionic compound. Notice here that we also start with C. It has to start with C because the metals are always first in our ionic compounds. We will always be able to predict the products of a double replacement reaction, and this is something that you need to be able to do. So, taking a look at these, two things are replacing each other. So we can split up both of our compounds into its ions. So copper nitrate, split up our silver and our carbonate. Copper is going to go with carbonate and silver is going to go with nitrate. But guess what? We are making new ionic compounds again. We're going to have to balance our charge. So when we go and balance those charges, copper is a 2+ charge. We know that copper was a 2+ charge whenever we look at the copper nitrate. Nitrate is -1, so that 2 came from the charge of copper. Carbonate, we should know its charge. It's CO3 2-, so we only need one of each ion, CuCO3. And we have our silver nitrate. Silver, we need to know, is always +1. Nitrate is NO3 -1, so just one of each of those ions as well. We have to get the correct chemical formulas. Then, once we have the correct chemical formulas, we can go and balance. So, when we go and balance that, we're going to end up getting, we need 2 silvers and 2 nitrates, so 2 silvers and 2 nitrates is what we'll get there. Take a second, pause the video, predict the products of this next reaction on your own, and resume when you're ready to check. So here we're going to end up making lead sulfate. Lead is 2+. We know it's 2+ from looking at this first compound it was in the lead chlorate, because chlorate's -1. With sulfate is SO4 2-, so we get PbSO4, one of each ion. Sodium is +1, and then our chlorate is -1, so one of each of those as well. Balancing wise, we need 2 sodiums and 2 chlorates. So again, we still always have to be crisscrossing for those new ionic compounds, and make sure your new compounds are a positive cation with a negative anion. We can't put 2 positives or 2 negatives together. Our very last type of reaction is combustion. Combustion is when we're taking a compound, which is normally a hydrocarbon. It contains carbon, reacted with oxygen gas, and the products are always going to be carbon dioxide and water. So regardless of that hydrocarbon that we're starting with, it could have a different number of carbons or a different number of hydrogens. We will always react with oxygen. We will always form carbon dioxide and water, and then we simply go and balance it. So let's go ahead and try this out. I see this first reaction here. We have a hydrocarbon reacting with oxygen. This must be combustion. Combustion always makes CO2 and water. Then we need to go and balance it. I need 6 carbons on both sides. 6 times 2 gives me 12 hydrogens on both sides. This is a total of 12, 18 oxygens, so 9 times 2 gives me 18 oxygens. Go ahead and give the second one a go. Resume the video when you're ready to check. So again, we have our hydrocarbon reacting with oxygen. This is always going to form carbon dioxide and water. This time I look and see that my 18 divided by 2 is an odd number, so I know I'm going to need to start with a 2 up front. You may have gotten to the point where your oxygens did not work out, so you started with that 2 up front. We need 16 carbons on both sides. 18 times 2 for 36 hydrogens on both sides. That gives me a total of 50 oxygens on my product side. So then 25 times 2 gives me 50 on the reactant side. So we're going to have all these different types mixed together. You're going to need to be able to recognize what type of reaction a reaction is, as well as predict the products. So to recognize each type, since we're going to have to predict the products a lot of the time, we need to be able to recognize it by looking at the reactants. Whenever we have an element plus an element, so just 2 elements, that will always be synthesis. We're going to stick our 2 elements together, balancing our charge to get the new compound. If we only have a single a single compound as our reactant, nothing else, just one single reactant, all we can do is break it down in decomposition. An element plus a compound will always be single replacement. 2 compounds will be double replacement. And then if we have our hydrocarbon reacting with oxygen, that will always be combustion. If we look at the products, we can easily tell that combustion is going to be those ones forming CO2 and H2O. That is the only really constant there looking at the products. So you have some practice that follows on the rest of page 17 and onto page 18. These are going to be your next stamp. We're going to look at a couple of these together. So looking at those first few on 17, we want to predict the type of reaction and balance it. So when I look at this first reaction, I see that I have zinc, which is an element, plus a compound. Well, element plus compound is always single replacement. We can go and balance this. We would need 2 H's and 2 Cl's. If we look at number 2, I have my hydrocarbon plus oxygen. We're forming CO2 and water. That's always combustion. We can go and balance this as well. We need 3 carbons, 8 hydrogens. That gives me a total of 10 oxygens. 5 times 2 is 10. Looking at number 3 here, we have 1 single compound. If we have 1 compound, we're breaking it down. That's decomposition. And then we can give that a quick little balance. So that shouldn't be too bad. On page 18, we're a little bit more involved. We want to determine the type and predict the products and then go and balance. So when I look at number 1, I have a compound plus a compound. That's going to be double replacement. So in double replacement, we have to split up our compounds. Our outsides go together and our insides go together. We also have to make sure we crisscross or balance our charge to get the new compounds. So we have silver, which is +1, going with chlorine to make AgCl. And then we have calcium, which is 2+, going with nitrate, which is an O3 - 1. And so our calcium nitrate will be this guy here. Once we have those correct chemical formulas sorted out, we can go back and balance. I'm going to need 2 nitrates on both sides, which gives me 2 silvers. 2 silvers gives me 2 chlorines. Oh, I already have 2 chlorines, so now we're balanced. Taking a look at number 2, we see element plus element. Well, element plus element is always going to be synthesis. We have a metal plus a non-metal, so we're making a new ionic compound. Again, for those new compounds, we have to balance our charge. Al3 plus Cl is -1, so we get AlCl3. And then we go and balance it after to make sure we're following the law of conservation of mass. Lastly, number 3, we see our hydrocarbon plus oxygen, which is always going to be combustion. And what does combustion always make? Carbon dioxide and water. Then we're going to need to balance it, so we'll need 2 carbons on both sides, 4 hydrogens. So that ends up giving us 6 hydrogens here, so 3 times 2 will be 6. So you have the remainder of these pages to practice and finish for a stamp. But hopefully types of reactions is clicking for you.